Good morning everyone. Today we are going to discuss about what is power factor and its importance, what are the causes of low power factor, what are the disadvantages of low power factor. All this will be discussed. What is a power factor? Initially, what is a power factor? Power factor is the cosine of the angle between voltage and current. Voltage phasor and current phasor. If you apply if the phasor, two phasors, voltage phasor and current phasor, the angle is phi. Assume that if you apply the cosine of the angle between voltage and current, it is called power factor. Another definition of power factor is it is the ratio of active power to apparent power. Active power is VI cos phi divided by apparent power is VI. At the same time, what is power factor from the circuits? If you know the resistance, if you know the impedance, what the power factor is cos phi equal to R by Z. That is resistance to the impedance is called power factor. Cos phi we can calculate. The importance of power factor, let us discuss now. Power factor plays important role in consuming power of electrical apparatus. If you saw the transformers, if you saw the motors, induction motors, they consumes high reactive power. Hence, the power factor will be low. If the power factor is low, what are the disadvantages? What are the disadvantages? First, listen carefully. First one is the equipment. Current drawn by the equipment will be increased. How it increases? The current is inversely proportional to the power factor. If the current increases, what about losses? Copper losses, I square R increases. That means for low power factor, copper losses will be increases. If the losses are increases, the efficiency will be decreases. This is one of the disadvantages of low power factor. If the current increased by the equipment, then what is the conductor size? Conductor size also required for the equipment increases. Therefore, we have to improve the power factor, maintain nearly 0.8 to 1. That is, current drawn by the equipment will be increases. At the same time, conductor size increases, power losses will be increases. That is the disadvantage of low power factor. If you increase the power factor, what happens? The current drawn by the equipment will be decreases. Current drawn by the equipment decreases, conductor size decreases, kVA rating of equipment will be decreases. This is the disadvantage of low power factor, improving the power factor. Now, what is the power factor? How to improve the power factor? What are the power factor calculations? All will be discussed in this video. Before going to discuss about power factor, we have to know various powers. What is real power? What is apparent power? What is reactive power? What is real power or working power? Real power also called as working power or true power, it is also called as. Real power is given as the power which is actually consumed by the load. It is called real power. Reactive power, the power which is consumed by the load to produce magnetic flux. That means magnetic parts of the machine will be uses reactive power to produce flux. The importance, one point is, what is the importance of reactive power is to produce the flux. We can say one example, what is reactive power? You are coming to the college at 9 AM every day or 10 AM. Before coming to college, what are the things we have to do in the home? First you are wake up, after that fresh up, after that eating food or lunch or breakfast, coming to the college. Actual thing is, in the college you are listening the classes. Listening the class is the active power, and whatever the food you taken, what are the things you did in the home, that is reactive power. Reactive power produces the flux to run the motor. Running the motor we can observe, but flux can be observed. Magnetic flux can be produced by reactive power. Is it right? Next is apparent power. It is the vectorial sum of active power and apparent power. It is denoted by S. S equal to square root of P plus JQ. Next, reactive power. These are the various powers related to power factor. Before going to discuss about power factor, a power triangle explains what is power factor. You can see in the notebook, or I will make a notebook. After that I write. Please follow that. The real power, reactive power, apparent power, all these comes under one power triangle. That power triangle is shown in this video. By taking a notebook, I am explaining that. Please follow that. Now I explained you what is power factor. Power factor of electrical system defined as the ratio of real power to apparent power. That is, real power is denoted by VI cos phi and apparent power is VI. The real power by apparent power, you will get VI get cancelled, you will get cos phi. It is defined as the ratio of resistance to impedance. If you take the power triangle, impedance triangle, it is not power triangle. R and X is right angle to that, and this is impedance. Then the angle between R to Z is called as power factor cos phi. It is another definition of power factor. Cos phi equal to kW. kW divided by kVA is gives power factor. Next, what are the powers? Real power, reactive power, apparent power, all these will be. This is the power triangle. You can see this is the real power and it is denoted by P. It is mentioned in kilowatt, measured in kilowatt, and it is the reactive power. Reactive power will be right angle to this, and kVA is the hypotenuse. If you apply the cosine of the angle between this, it is opposite side, it is adjacent side, it is hypotenuse. If you apply the cos phi equal to kW by kVA. Therefore, power phi angle explains how to calculate the power, how to calculate the reactive power. If you want reactive power kVR, P into tan phi, you will get reactive power. kVR equal to reactive power kVR equal to power into tan phi. If you improve the power factor, another one, this is the cos phi 1, then it is a kVR 1. Then if you improve the power factor, reactive power consumed by the load will be decreases, and this will be supplied by capacitor. Capacitors are the synchronous motors or synchronous condensers or produces reactive power. Reactive power supplied by capacitor it is. What are the causes of low power factor? You can learn from this. So many industries utilizing induction motors as a load to run the machineries, hence the power factor will be low. The induction motors are the main cause for producing the low power factor, whereas transformers also magnetizing components are there, whereas induction motors also magnetizing parts are there, hence the induction generators discharging lighting, all these comes under what are the causes of low power factor. Induction motors are the key role to reduce the power factor, but that is a disadvantage. Therefore, we are using capacitors in industries. Effects of low power factor. One important effect is, we know that P equal to VI cos phi in real power, I equal to P by V cos phi. From this relation, I is inversely proportional to cos phi. Hence, if your current increases, power factor will be reduces, or power factor reduces, current drawn by the equipment will be increases. If current drawn by the equipment will increases, what happens? The power drawn by the equipment increases, hence the current drawn by the equipment increases. If the current drawn by the equipment increases, what happens? The equipment may damage due to excessive heat. At the same time, losses will be increases. Which type of losses increases? Current increases means copper losses. I square R losses will be increases. If losses are increases, what happens? If losses are increases, efficiency will decreases. Efficiency will be decreases. Output by input, output will be decreases if the efficiency decreases. Next, kVA rating of the equipment increases, because current increases means kVA means V into I. V is constant, I increases means kVA rating, VI equal to kVA it is. I increases means kVA rating of equipment will increases. kVA rating of equipment increases. kVA rating of equipment increases.